Welcome back, Math 20-3. Today's lesson is basically part 2 of chapter 5.2, which is about how can we draw or sketch two-dimensional representation of each of the views, basically. And it does involve three-dimensional object. However, we didn't do any calculation last time. We only did how can we sketch from the front view, side view, top-down view, those kind of situation. And just to give a little recall, the page that we were at was 245, and we did this bird cage example. Now, we are going to go to class example number 2, which is on page 249. You may notice that first half, I am going to use this booklet, that my class note that you can find from Google Class. You can go to your workbook too, like what I put, page 249 over there. The only problem is, like I mentioned, we need to draw at the end, but the finished product is given on workbook. So I recommend rather use blank pieces of paper. Especially when it comes to today's lesson, I'm gonna use a blank pieces of paper. You will find it like this as a class example. It's not even from a workbook. So have that in your mind. So let's get this started. Now, unlike the previous example, you are now have some kind of measurement. I am just gonna change my sheet. There you go. That makes my life a little better. I'm gonna read the question first. Edison is building a toy box for his son in the shape of rectangular prism. The box is to be 120 centimeter, which is my width, 60 centimeter, which is my length, and 60 centimeter, which is my height. Draw the component parts using a scale of 1 to 15. Now, we need to understand about this scale factor as a little recall. So, scale factor, if you don't remember what it represents, was a comparison between original versus the model. So, when it comes to an actual, actual factor situation, here is a formula that you need to understand. We call it formula because it doesn't alter. It's always model dot original is equal to scale factor. Have that in your mind. Now, why I'm going into this formula is because we're going to use this 1 to 15 ratio for every single situation. So we're going to do first width, we're going to do second length, we're going to do third height, and then we're going to draw the whole thing. So without further ado, let's get this started. The question says the model to original ratio is 1 to 15. So I want you to put that. Now, original value is given, but width we don't know. So I'm going to put width for the model drawing components part as a W, dot dot. 15 was my original, and my original actual value, what you see over here, is 120 centimeter. I want you to have that. And now, after that, the ratio was simple. Whatever you multiply inside should be equal to what I multiply outside. So 15W, that is equal to 120 centimeter. Some people say, Mr. Kim, can I just make it as an X? Feel free. Then 15X is equal to 120 centimeter. You may notice that I keep the unit just because that helps me how can I draw things easily. Now W, opposite operation, 15 and W, they're multiplying each other. So divide is what you need to do. Divided by 15 on both sides. So 120 divided by 15 centimeter. That's what you have. And whenever you put the value 120 divided by 15, it gives me 8 centimeter. That is my new width. As you may notice, I put a little apostrophe over here because if I assume W as my actual width, W with the apostrophe is my model's width. You can think it in that way. Let's do the same thing for the length. Now length, here's what I'm going to do. Same thing, 1 to 15, length apostrophe, dot dot, and we have 60 centimeter. Whatever that I multiply inside should be equal to multiply outside. So 15L, that is equal to 60 centimeter. And L is equal to 60 centimeter divided by 15. And that becomes 4 centimeter. People who like to think math in an easier way, you may notice that if I compare the value of width and length, as you may notice, length times by 2 is 120 centimeter over here, because 60 times 2 is 120. If it's other way around, 120 divided by 2 is 60. So if you want to make your life a little easier, as long as you figure out the ratio between 2 to 1 between width and length, you can actually figure one of them using ratio and another one just use the same thing, like 8 to 4, because it's 2 to 1 in this situation. You can do that because our scale and ratio, that should be applicable for every single measurement. Now height, but since we're doing practice, I'm gonna go with what we know. 15, that is equal to height, dot dot, 60 centimeter, whatever inside, 15H is equal to 1 times 60, 60 centimeter. It's multiplying together, so opposite of multiplication, division. 60 divided by 15 is 4 centimeter. Now we found 1, 2, and 3. Our each of situation, whatever the rectangle that I have, front, back, the only exception, oh sorry, not a rectangle. It's rectangle at certain ones, and then there's square to be fair for some others, but in any case, we found length, width, and height. Length and width create rectangle. Height and length, it turned out it's the same part, so it's square. So we found our model length, width, and height. Now, using this, what we're going to do is we're going to draw. And you can actually use the scale that we know. Like what I mean by that is I need to draw front and back and the bottom, if you will. So we need to do several parts. Let's talk about front and back first. When I look at front and back, I need to draw, oops, there you go. Front side of view. That's what I need to put for front and back. So I can draw front and back as height, new height, and width, new width, which is 4 centimeter and 8 centimeter. So what I can do is literally take out my ruler and I can draw 8 centimeter. Then I can draw 4 centimeter like that. And I can say from here to here is my new width, which is 8 centimeter. From here to here is my 4 centimeter, and that is my new width and then new height. That's my front and back. if you want to do, and it just turned out that front and back, which is 120 and 60, if I look at the bottom too, it's 120 and 60. So it's just this specific situation. Yes, I know that front and back is most common one, but this also can apply for my bottom drawing. So you don't need to draw the bottom. Now, when it comes to side by side, we need to consider this surface, one on the right, one on the left. They are actually equal together. So what you need to do is use a scale 4 centimeter. That's a little bit too below. I hope that helped you. And then 4 centimeter. I know that it go off the grid a little bit, but please understand that is my side view. That worked really horrible. Let's make it straight. That's a little better. That's my new height, which is 4 centimeter. That's my new length, which is 4 centimeter. You can go in this way. Now, next example, I want to create a new example. And that's the one where, let's do some specific example. Oops. Sorry. Let's say I am making, this is class example. It is neither available on your workbook or class note. Let's talk about a cylinder. And I'm going to create really big example. So let's say this is 100 meter. And when it comes to this, we are having 55 meters, something like that. So we have radius given 55 meter and height is given 100 meters, something like that. Now, although the question doesn't give you a specific ratio change, but this time, let's say we're making this into a smaller scale, and the ratio scale factor is 1 to 20 ratio, something like that. Always remember that when it comes to this, 1 is basically model, 20 is basically my original. Now, know the fact that when it comes to the situation, it is done as a meter, and we are not going to draw the whole thing as a first step. We're going to do, first step, calculation of ratio. That should be my first. So here's what I'm going to do. This time I'm going to do Canadian math method, which is the one that use fraction. So model to original is 1 to 20. So here's what I put. Model, put it at the top. Original, put it at the bottom. Know the fact that I need to do ratio first. Sorry, my puppy's going crazy at the background, so please understand that. Biscuit, shh. Sorry about that. Yeah, now the background noise should be stopped. But in any case, let's do a radius part first. When it comes to Canadian method of using ratio, we like to go through as a numerator and denominator. It doesn't matter which one you put. Honestly, my favorite is putting unknown on the top because that makes my life a little better. But here's the thing. Talking about unknown, we need to figure out the new radius for the model. The real radius was 55 meter, like that. As you may notice, my unknown is on the top. So opposite operation, multiply by the denominator for both. Bottom will be gone. And now it's 55 meter divided by 20 is equal to my new radius. That gives me 2.75 meter for my new radius, basically. Let's do the same thing, except it's a height, new height perspective. Note the fact that it's 1 over 20 instead of 1 dot dot 20 in this situation. Height, new height, over what we know, 100 meter. We do not want to have this divided by 100, so opposite operation, opposite of division is multiplication. That's what you need to do. And now 100 meter over 20, which is 100 divided by 20, is 5 meter, and that is what we have for the new height. This ratio calculation for each of the measurement is what we need to do first. But once you get this rolling, the second part is drawing our two-dimensional diagram for each of the faces. That should be relatively easy because we're using those two. I know it's a meter, it's in meter, but I'm gonna use my meter as if it's a centimeter, if you will. So, top and bottom. Top and bottom basically look exactly same for this diagram. It should be circle because it's that over here. I don't have a good circle, but I'm gonna use my 2.75 as radius. Honestly, I don't have a good compass either. .75 meter for this. Is it actually? It's getting there, but let's assume that 2.75. I should have used a little bigger compass, but in any case, after that, we have you will know why I'm putting 5.5. I'm gonna tell you later. 5 meter. So here's the thing. Height is an easy one. That's R. That's H, which is 5 meter. As you may notice, I'm not putting 2.75 because if you think about it, 2.75 is just a halfway for my radius for the side view. So if you want a front view, if you will, front or side, front and side, if it's a perfect cylinder, they should share the same amount. So in either case, you may notice that I'm putting the whole diameter instead of radius, which is 5.5 if you multiply 2.75 together. And that is my two-dimensional diagram for top bottom, two-dimensional diagram for front and side, and that's what you need to do. That is today's lesson. Your homework, I want you to work on your workbook problem, page 250 and 252. I want you to do several questions in here, but there are 5, 6, 7. I want you to work on those 3. Let's see, label the dimension. Actually, when it comes to 7, oh, everything is labeled the dimension. That's good. Drawing part, I want to put in this way. Focus on ratio calculation and new label. If you don't draw the diagram, I am perfectly okay too.